silence though. Test, test. JJ, say something. Anxious and nervous.
Do you stage fright?
Yeah, a lot.
Screenomatic chef.
Yeah. All right. So yesterday we were doing. I'm just gonna try to forget that thing's recording. Yesterday we were doing the design a cylindrical can. It needs to hold 1 liter. It has to use the least amount of material possible. That would be important to us because we want to make sure that we're making a profit. So our volume we said was pi r squared h, and that was 1 liter. Then we had our surface area equation, and we figured out that the thing we're trying to optimize is the surface area, and in order to eliminate the 2 variables h and r that are in the surface area, we needed to use the volume equation. So, and we determined that the domain was that we couldn't include a radius of 0, but we could have any positively sized radius. Did you guys figure out what are our critical points?
Point 4, 5, 4, and 2.
And how did you find that?
I set the derivative equal to 0.
Yep. Why wouldn't we look for, so we know we have critical points when when the derivative is equal to 0, but we also have critical points when the function's undefined, right? Why wouldn't we be looking when the function's undefined in this case? It can't be, but not for that reason.
Our domain.
Yeah, our domain. The only time this function's undefined is when we have division by 0, and we've already said that the domain's not allowed to include 0, so we're safe there. We also, since we know that r can't be equal to 0, we can multiply by r and get rid of some of this stuff. So we're going to end up getting 4 pi r cubed equals 2, or r cubed equals 2 over 4 pi. And that would mean that r is equal to 1 over 2 pi to the 1/3. And we just need to figure out if that's a max or a min. Remember that, so we only found 1 critical point, but we're not guaranteed that this critical point is going to minimize the amount of material that's necessary. If it doesn't, there may not be a solution, or if our domain is closed, we need to check the endpoints. So we're going to take the second derivative real fast. And what am I going to get when I take the derivative of the first term, negative 2 over r squared?
4 over r squared.
Yep. I'm going to bring the negative 2 down. I'll get 4 over r cubed plus
4 pi.
4 pi. Good. And at this point, we're not, now in the last section, you guys are used to like that mechanic now, right? Like, okay, I got to find the point of inflection. I got to find where it's concave up, concave down. We don't care. Someone making a soda can doesn't care if the function is concave up, concave down. What they care about is this actually a minimum? We wanted to minimize the surface area, so is this actually a minimum? So how are we going to do that?
Find the second derivative. Oh wait, we did. Forgot. I just did that. And then plug in 0.54 cubed.
Right. We're going to plug in this point and figure out our critical point. We're going to plug it in there, figure out if this thing's positive or negative.
When I typed
It's
in,
not 0.5.
yeah, I
it's
got
1.16.
1.16.
Yeah,
Okay.
1.16.
Maybe double check the old math.
Draw the
R
window.
squared plus 4 pi r.
It's the third with the cube root.
It's not.
Is that what you're doing?
It might have been that.
No, for the first derivative.
Yeah.
But it's
When I used the cube root button, it
Yeah,
gave me 542, 0.542, but when I used to go 1/3, it gave me 1.16.
When I used
Let me
to
see how you typed it in.
Oh, the first time I did it like, maybe I just did it.
Uh-huh.
And
Oh,
then I did
it's
1
1
pi
over,
that.
it's 1 over 2
Yeah,
pi.
and then I did 1 over that.
No, you can't do it that way.
Oh, okay.
Yeah. Oh, no, no,
I
you
got
should be able to, no,
I
you
got
should be able to do it that
Yeah, I
way.
got it that too though.
Point
Well,
542.
Yeah, it's the parentheses. You have
Yeah.
to have the right amount of parentheses.
I put
Yeah.
parentheses on both and I got 1.16. If I'm,
You gotta.
When you
Like
do
that.
0.542.
No,
Yeah.
you're taking the cube root of 2 pi, not
But I mean,
going to the
for
pi.
I just
the
did
no,
one
like I
over
did
two
that.
pi.
I put
Oh,
pi.
yeah.
I just did 1 over 2 pi, and then I did
We
cube
did
root
the same thing,
answer.
just different.
Yeah.
Yeah.
And then that's like
It works
That's
both ways.
strange.
It should, yeah, it should
Yeah,
work both
it-
ways. Yeah. But
That's-
it is a parentheses problem, so if you're not putting the 2 pi in parentheses,
Go
you may not
parentheses,
be,
quick.
yeah,
That's my rule.
you may not be
Wait, so
doing it properly.
So what's it gonna end up
usually
being?
Here, let me, I need to, come on now, thank you. All right, so you should type it in. You can do it a couple of different ways, but I'm going to type it in this way. 1 divided by the quantity 2 times pi. All to the 1/3.
trying to challenge me.
What?
Oh, that's so weird.
I don't get
So
it.
if
I'm
the
confused.
problem is you didn't put parentheses around the 2 pi,
Right.
so it thought it was pi over 2. So
Wait, what? But if I put,
If you're just doing the cube root of, like if you do 2 pi and then just type the cube root button, you might only be taking the cube root of pi.
but then why, I did it here, like why doesn't it work if I do that?
Because you're doing 1/2 times pi. You see how I have parentheses on the 2 pi?
Yeah.
If I do 1 divided by 2 pi, that is not 1 over 2 pi, that's 1/2 times pi. And we can see that 1.57 is about 1/2 of pi. Right? So when you have division, you have to have parentheses around everything you're dividing by.
this is crazy. Rule number 1.
Okay? Did we get that sorted out?
Yeah.
Okay, good. All right, so yeah, so that would be what's going on there. We're going to plug that answer in to the second derivative. But in this case, do we really need to spend a lot of time evaluating the second derivative? Why not? We know it's positive. That's all we care about. We don't care what the number is. If it's positive, we have a min. If it's negative, then it's concave down, and we have a max. So this number is positive. All these other numbers are positive. So it's clearly the second derivative evaluated at this point is clearly positive. So we're a smiley face, which means we've got a min.
So when you say that you know that the second derivative is positive, why are you saying that?
So 1 over 2 pi to the cube root is a positive number.
Yeah.
4 divided by a positive number is a positive number. Positive number plus 4 pi is a positive number. Yeah. All right, so we definitely know it's a min. The question asked us to find the value for h and r. So we can't stop here. We actually have to figure out what h and r is. So we know r. We just typed it into the calculator and got that it's approximately 0.54. Let's round to the third decimal place. We'll have 0.542. And then we can determine what h is because we know that 1 liter where's our 1 liter equals pi r squared h. And we can solve for h and say that h is equal to 1 divided by pi r squared. And that's approximately equal to and again, let's type this in. Let's use plenty of parentheses. So we're going to have 1 divided by open parentheses pi times r squared. In this case, I solved for r. We said it was 0.542. So we'll square that. We're going to close the parentheses so that we're dividing by the whole thing, pi r squared. And that should give us a height of about 1. We'll say 1.08.
You only record for a certain amount of time.
Yes, 15 minutes.
Super.
Good. You let them know.
You better.
Okay, so here's a question. We haven't been writing the units at all. What are the units? Is this can 1 millimeter high? Is it 1 mile high? Yeah. How do we know?
I did a foot.
Oh, okay. So we just guessed. Yeah, it's a foot. What, for those of you guys that are in bio, maybe you remember this because it's something you need to do a lot, but what is the volumetric unit for 1 milliliter? Cubic centimeter. So what's the volumetric unit for 1 liter? Cubic meter. So we've got, this is a meter, and this is half a meter.
Wait, what? Milliliters, liters is thousand.
Mm-hmm.
And centimeters to meters, 100.
So let's look at it. We know, you know that 1 milliliter is equal to 1 cubic centimeter, right? 1 centimeter cubed. Basically, if I had a little box that was a centimeter by a centimeter by a centimeter, then it would hold 1 milliliter of fluid, right? So we want to convert that to liters. So like Maddie was saying, we need to multiply both sides by 1,000, right? So we're going to get, in this case, we're going to get 1,000 milliliters equals 1,000 cubic centimeters. And so this is 1 liter equals 1,000 cubic centimeters. And so maybe we want to convert that into meters. So it doesn't look like it's going to be meters, does it? No. So if I want to convert that into something that doesn't have like a coefficient in the front, then I need to make my box. Well, we're talking about like a cubic unit. So each of my units, if I'm making a cubic unit box, then my unit's going to show up 3 times, right? So what is the cube root of 1,000? 10. So this is actually 10 centimeters cubed. And what's 10 times 1 centimeter? You said it a second ago. Say it. So you guys don't use this unit very often, but what's a decimeter? Yeah. Great. Excellent. So yeah, so this is a decimeter cube. So that means that our can is 1 decimeter high and half a decimeter in radius about. Or we could, if we wanted to convert that into millimeters, we could make it a little bit bigger. We could say this is, 54.2 millimeters and 108 millimeters. If we wanted to do some unit conversion to put it in maybe a unit that